In most data science projects, whether you're doing machine learning, web scraping, data processing or analysis, you're going to have a bunch of configuration settings somewhere. But what's the best place to store these settings? And how do you design your code so that your settings are easy to find and easy to change? I'm going to give you a few tips in this video. Apply them to a data science example, and I'll also talk about a really useful package to help you with this. If you want to improve the way you design your software, I've written a free guide for you that helps you with this. It's available at ArjanCodes.com/design guide. It takes you through 7 steps to consider when you create a new software application. It's really practical, to the point. You can apply it directly to the code that you're working on. So get it at ArjanCodes.com/design guide. I've also put the link in the description of this video. Now let's dive into the example. If you watched some of my earlier videos, you might recognize this example. It's an example that uses Torch to create a model, a linear net, and then runs a bunch of experiments on test data. It's an image classification problem. I recently refactored this whole project as part of a code roast. If you haven't watched that yet, I've put a link to that video in the description of this one. What we've ended up with in the final version is a main file that contains a bunch of parameters. So these are epoch counts, batch sizes, path where we output logs, data configuration stuff, data directory, data files, etc. etc. So these are configuration settings for this project, and they're all in the main file defined as constants. If you look at the main function itself, you see that these constants are then used to create, for example, data loaders. They're being passed to the experiment tracking system. They're being used in running the epochs, and so on and so on. So these settings, they basically flow through the rest of the code from the top, which is nice because then we have all these settings in a single place here in the main file. In the original version of this project, this wasn't the case at all. Let me open that so I can show you what I mean. So here, this was the original version. It's defined differently. There are a couple of parameters here, which is a good thing. But if you look at other files, like the load data file that you see here, you see that there is configuration settings here. Here's the directory. Here's references to explicit images. And that makes it really hard to get a clear overview of what the configuration settings for a project are exactly. Because even in the main file of this original version, you see that there are some parameters here. But if you scroll down, there's actually a parameter, extra parameter in other places as well. Like here, where we're defining the TensorBoard experiment, we're passing a log directory, which is built on this particular route that we provide here. So in the original version of this project, you basically had to look through all of the code to find out what the configuration settings are. And what I did in the updated version in that video is put them all together in a single place here in the main file. That's better, but it's still not ideal to have these configuration settings in your code directly, and that's for a few reasons. The first reason is that suppose you want to have colleagues use your script to perform various kinds of experiments, and maybe those colleagues, they don't know how to code in Python. Well, now they have to dive into Python files and change values here, which is going to be really hard for them. Another reason is that this still invites you as a programmer to define these configuration settings everywhere in the code, because there is nowhere written here that you should only put them here, right? And often it's easier. You just say, oh, you know what? I just put it directly in this file and I don't have to worry about passing it to the function or whatever. By leaving these configuration settings explicitly in your code file, you're actually promoting bad practices for dealing with configurations. And that ties in closely with the third reason, which is that if you put your configuration settings outside of the code, it means you can also change them without changing the code. And not having to change the code when you want to change the configuration is valuable, because that means that you can do other things then, like suppose you want to run this experiment 5 times, but each with a different bunch of configuration settings. The way it's set up now, this involves manual work, because every time you need to run the experiment, then you need to manually change the values of these configuration variables here and then run the experiment again. Whereas if the configuration settings are stored outside of the main code, then you can basically write a script that runs the experiment 5 times with 5 different files. And you could even generate different configuration settings on the fly using randomized values or whatever you would like to do. So in general, moving out configuration settings from your main code is really important, and it's going to help you write more flexible Python scripts in the end. So that's what I'm going to do with this example today. Before I start modifying this code, I want to talk about cohesion and coupling and how configuration parameters interact with those concepts. If you run this code, then this is what happens. So you see it's training and validating data, and it's retrieving all the data from the files that we defined using these parameters here. So what makes dealing with configuration settings so hard? Well, the first issue is that you're going to need them in a lot of different places in your code. If you have a machine learning model, you might need a path to the input data. You might need to specify the files that contain those data. If you have an experiment tracking system, you might need a path to store experiment logs. If you're doing web scraping, you might want to have a bunch of URLs that you define somewhere from where to get the data. So all these things are configuration settings that are basically spread throughout your entire code base. On the other hand, you want to have a single place where you define them, because otherwise it's impossible to keep track of all the settings that are there and that you might want to change in the future. This seems to lead to an unsolvable problem. If you store your configuration settings in a single place, you're going to need to pass them around everywhere, leading to functions with loads of arguments, passing detailed configuration settings down to lower level functions, leading to weak cohesion. On the other hand, if you define the config settings as a global variable somewhere that you import in all those different files, then that's going to lead to a lot of coupling, because if those config settings are not there, then your code is also going to break. In the example, I basically stored all the configuration settings in the main file. Now, for a very simple project like this, that's not really that much of a problem. But if your data science projects grow larger, you don't want to have to store a bunch of configuration settings in your main file. That's just going to clutter up everything. So what are a few other solutions to dealing with configuration settings? Well, the first one is that you could define each setting locally near or in the file that it's going to be needed in. That way it's also clear which setting is going to be used where, and it also provides a kind of structure. The disadvantage is that then you'll end up with having settings all over the place in your code, and they're going to be harder to find. A second solution is that you use environment variables. There's a package you can use for that. It's called python.env. That's really useful. And the way that this would work is that you would define a bunch of environment variables containing all the settings you need, and then the code, the script, basically accesses those variables and then uses the values that are stored in them. The advantage of this approach over directly defining the settings inside your code file is that you can then change them and run the code again without having to change the code. A package like python.env is really useful because that allows you to create .env files that then contain the definitions of those environment variables in a single place, which is pretty nice. The disadvantage is that from the code it's not directly easy to see what configuration variables there actually are and which ones you can change. And also there's no structure whatsoever to these variables. So you might end up with a huge list of unrelated variables that all have different kinds of values. And as a result, you might not know which variable is going to be used where and what the effect is going to be of changing the value of that variable. A third solution is that instead of a .env file containing environment variables, that you use a JSON or a YAML file that contains the specification of your settings. The nice thing about this approach is that you can then also provide some structure. So for example, you could make sub-objects that then correspond to different layers of your application. There's a really nice package called Hydra, and that allows you to do lots of things with configuration files. You can define YAML files containing configurations, sub-objects of configurations. You can even define configurations in multiple files, override configurations, pass configuration options as command line arguments when you run the script, create batches of configurations and run your script multiple times, and many more things. And that's really useful if you're running experiments and you just want to run a bunch of those, changing some values without having to change the code. So let's take a look at the example and see how we can use Hydra to improve our configuration setting management. With the Hydra package, you can put all of these parameters into a YAML file, and that really cleans up your code a lot. So as a starting point, let's create a simple YAML file that contains these parameters. So the epoch count, the LR, and the batch size, which is really more the algorithmic parameter, so to say. So what I'm going to do is, in my source folder, create here a new folder called conf. And this is going to contain all our configuration settings. So I'll put a simple YAML file in here called config.yaml. So this is going to contain all the settings that we want to have. What I'm going to do is simply copy over these parameters here, the epoch count, the LR, and the batch size. So let's for now just put that here. Obviously this is not correct YAML format, so we have to change this a little bit. Let's say we define a section here that we call params, which is what these things are. And I'm going to select these and indent them. And by default in YAML files, you should use lowercase names. So let's change this to epoch count. And we use a column to assign the value. So this is what we get. There we go, that's a very simple set of parameters. And what do we need to do now to import them in our code? Well, that's actually really simple. As first step, let's import Hydra. And then what you need to do, let me go to the main function here, is put a decorator on top of the main function to make sure that Hydra knows that it needs to load the configuration before it runs this main function. And this is what that looks like. And we need to provide two things. The path where Hydra can find the configuration, so that's the conf folder that I just created, and the name of the config file, which is config. And then what I need to do is add an extra parameter to my main function. Let's call that config. I won't deal with types yet. I'll show you in a minute how that works. So what happens now is that Hydra will automatically load the configuration file at this location and put the data into this object that you can then use in your main function. Let's print this and see what we get. And I'll just return after the print statement so we don't do all the other stuff. If I run this, then you see that Hydra loads the configuration file and we now get the data that we put in there. So if params.epochCount.lr.batch size. And we can now access these things through the config object and use them in our code here. So this is really useful. Let's also put the other configuration settings in that same configuration file. So we have params now. What we also have is a bunch of files. That's basically the files that you find here. So I'm going to add another group here called files. And this is what the file data looks like. So we have 4 files: test data, labels, train data, and train labels. And then a final group of parameters is the folders where we have things. So we have the log path and we have the data dir. So let's put those in here. I'm just going to call this log. So that's the runs folder, and the data folder is this. There we go. Now the thing is, what Hydra also does is it creates this folder containing outputs. So you can see that we have here per date a number of outputs. And basically this is a time slot. So this is the last time that I ran the actual code. That was what I just showed you. And that's where it's going to put all the things that are related to Hydra. And because Hydra does that, it also means that Hydra changes the working directory to the output directory. So what you need to do is to make sure that the files, the paths that you provide here are actually relative to the current working directory. And let me do that for data. Oh, actually these double quotes, they're not needed in YAML. So for data, what you can do to get the current working directory is use this. So this gives us the current working directory. Let's add a slash after that. And then we're sure we load the data from the right place. Now Hydra has a couple of other parameters as well that you can access in this configuration file using a similar structure. So that's pretty useful. You can even refer to other values in the configuration itself. So this is now our basic configuration that contains all the data that we need. So go back into the main file and let's print the configuration one more time just to verify that we're indeed getting all this information. So that's where you see we get all of these things, which is great. And now we can start using the values in this configuration object. And instead of using these constants here, I can use the values to pass them to the different parts of my program that needs it. Now, there's one thing that I'd like to do as well. You know that I love using types because they help me write code more quickly and more cleanly and make less mistakes. But configuration now currently doesn't have a type, so it doesn't provide any information about what it contains, and I'd like to change that. Now, fortunately, Hydra integrates really well with data classes, so you can actually use data classes to define what the structure is of this configuration object. So I'm going to add another file where I'll define the structure of this configuration. So let's call that config.py, and we're going to use data classes to do that. So what do we have as part of a configuration? Well, we have paths. So let's create a data class paths. And this is going to have the log and the data folder. Another class we have is files. And this contains the train data, which is a string, train labels, which is also a string, test data and test label. So those are the files that we need in this particular project. And then finally, we have a class params, which has the epoch count. That's an int. We have the LR setting, which is a float. And we have the batch size, which is also an int. So these are the sub parts of our configuration. And then finally, since this is a group of these configuration settings, we can define another data class. Let's call this mnist config, because this is using the mnist dataset. And this simply groups the parameters in instances of these classes that are just defined above. So we have the paths, which is something of type paths. We have the files, which is an instance of files. And we have params, which is an instance of params. So that's our configuration definition. The only thing we need to do now in the main file is make sure that config is actually of that type. Let me add this here, mnist config, and we're going to import that automatically. And now let's see what happens when we run this code. So you see that, well, there is an error here because we did not yet pass the right parameter values. But if we move up, we see that we still get the same object back. So it's not yet an mnist config, even though we provided it as a type. And the reason that's happening is because Hydra doesn't know we want to have something of this type. Hydra simply provides us with the raw data. So we need to tell also Hydra that we want config to be an instance of mnist config and not the raw data that it just loads from the configuration file. And the way that Hydra solved this, it's a bit convoluted, is that they have a config store, and then you can link configuration objects provided by Hydra with data classes that you want to use. So in order to do that, we need to create a config store. Let's do that here. That's a config store, and this is how we called it, config store.instance, and we need to import that. So now we have a config store, and then we simply need to tell it that it can use the mnist config data class. So we're going to store this with a name. Let's call that mnist config, like so. And we provided what they call a node, and that's mnist config, which we define as follows. And now let's run the code again. I'll make this a little bit larger, clear the screen. Let's move up. And now this is going to be an actual instance of the mnist config data class. So for example, what I can do now is print config.params. And if I run this, then we're going to see just the parameters here. So let's move up. That's where they are. So now the next step is that instead of all these constants that I'm using here in the code, I can now access them from the configuration. So for example, here, instead of accessing this config, I can write config.params.LR. That gives us the LR. And the same thing for all the other configs. So for example, the batch size is going to become config.params.batch size. .params.batch size. There we go. These constants I'll replace in a minute because there's an issue with it. I'll show you what I mean. Let's scroll down. So the log path we can also change. That's config.paths.log, and then we have the epoch count here, config.params.epoch count, and basically replace the constants everywhere. .epoch count here as well. Let's see, is there anything else? No, that seems to be it. So the only thing that's remaining is this test data and training data labels. Now, if you look at the definition of create data loader, what it expects is actually a path. But the problem is we now moved to a configuration file which doesn't contain path objects because that's a Python thing. It contains strings. And there you see that actually the way that I originally defined these variables was not very clean, because we have the data directory here and then I construct these constants directly from this value and also turn them into a path. So even then, if you want to change these values, there is some boilerplate code that's surrounding the actual value that you're concerned with. So now that we use separate configuration file, we can also clean this up. So first, let me delete these parameters because we don't need these anymore. And what you can do to clean this up is to slightly change the create data loader function to simply accept strings, and then create data loader will be responsible for constructing paths. paths from that. So let's save this file, and then I'm going to the definition of this create data loader function. So currently it's getting paths that already contain the data directory in front of it. So what we need to do is add another parameter in front that contains the data directory. So let's call that the root path. That's going to be a string. And then we have the data file, which is a string, and we have the label file, which is also a string. And now what we need to do is construct the data path and the label path from these strings. And that's actually pretty straightforward. I can simply define a data path here, which is a path, and that's built up from the root path and then the data file. So that's our data path. And similarly, we can make a label path. There we go. There's still some type errors here due to NumPy, so we'll just ignore that for the moment. But now create data loader expects 3 strings that we can simply supply from the config settings. So I'm going back to the main file, and now of course here I need to change this. So what I need to do is pass the config.paths.data, which is the root path. And then instead of these 2 constants, test data and test label, I'm going to pass the file names from the configuration. And the same thing for the train loader. So pass.data, train data, train labels. There we go. Now, if you want to make this a bit cleaner, because now there are lots of parameters that you're passing to this function, you could also use keyword arguments to clarify things. Like so. And let's do the same thing here. There we go. And now we can remove these settings as well, because they're now loaded from the configuration file. There we go. So that means we now no longer have any configuration settings here in the main file. Let's delete this import because that results in an error and it's no longer needed here. When you scroll down, you see that there is another type error here. That's one issue with Hydra and many other packages in Python, is that the main function here is empty, gets no parameters, but Hydra fills it with a configuration on the fly. So it doesn't really work very well together with the typing system, because the typing system expects that we should provide here a configuration. And well, we don't do that here because Hydra is going to do that. So in terms of typing, I think there is a couple of things to improve in how it works. But overall, I think this works really nicely and it gives a lot of flexibility. I'll show you a few more things in a minute. Let's first run this code and see what happens now. So you see there's an error now, no such file directory. And I think what the problem is that there is a double quote here that's not supposed to be there. So apparently I accidentally added that somewhere. Let's see, that's probably happening here. No, here that looks to be fine. Let's go back into the configuration file. There is still a double quote here, exactly. So that's always something to pay attention to when you're defining these configurations. Let's run this again and see if it works now. Yeah. There we go. So it's now training and validating again based on the settings in the configuration file. So you see that we have 20 epochs here. So let's verify that changing the configuration actually does something. So let's say I change the epoch count to 10 instead of 20. And then I go back into the main file. We're running the code again. And now you see epoch count is 10. And I was able to do this without changing a single line in the Python file. I'll simply change the setting in my configuration. So that's really cool. So that means what you can do now is provide this collection of scripts and configuration settings in the YAML file to a colleague, and they can simply run your script by using the configuration. If they want to change something, they change the configuration, then they don't have to look at your code. Here I'm using a single configuration file, but actually Hydra has lots of options of using files and folders and sub-configuration files, etc. And I want to show you one thing. For example, what you can do, suppose that you want to have different test sets and you want to be able to define those collections of test data beforehand. What you can do then is create a sub-configuration file for each group of data that you want to use. So let's say I create here a subfolder called files, and let me create another file here called mnist, which contains the MNIST dataset. And then you could potentially use other datasets as well. And the MNIST dataset is nothing more than basically these values. So I'm going to copy these to the MNIST file, remove the indentation here. Let's save this. And then what you can do in config.yaml is, instead of directly defining the files here, you can actually provide default values where you should load things from. So I won't define them here. I'll just add a defaults here, defaults, and that's a list. So for files, our default is going to be the MNIST configuration that we just created. And now if I run this, you see this is still working fine. And now we get the file data from the MNIST file instead of directly from the config file. And you can create any kind of combination or structure of configuration files that you want. Now you see that there was a warning here. Let me go back up where it says that the defaults list is missing self. So this is something that you need to do in Hydra if you define defaults. And that has mainly to do with the legacy issue, that they changed the way that defaults work from the current version to the previous version. So you have to indicate which version of defaults you'd like to use. The main change is that they swapped the order in which defaults override standards. So for example, if I were to provide a files thing still in here, then in the previous version, defaults wouldn't override the files already in the config, but this is actually often what we want. So we need to add here self. So that basically means we want files to be preferential over what's in the current file. That's what it means. And then let's delete this line. And now when I run this again, we should not get that error anymore. So there you go. Now it's running as it should. Let me stop this. We don't need to print these parameters anymore. So there you go. It's a really neat way of dealing with configuration settings. I still think it's a little bit involved with the config store and registering types and having the main function here that you have to call without a parameter and that Hydra then fills it in for you. To me, that doesn't feel like a great way of doing it. I would have actually preferred a simple function that gets parameters and that just does the job for you instead of all this complicated things with config stores and decorators and etc. etc. So though I do kind of get why they did it this way, because it's also really easy if you have a main function and you don't want to worry about passing objects around. But from a software design perspective, I personally prefer a cleaner approach. So overall, here's my advice for how to best deal with configuration settings. First, define your settings in a single place, outside of the code. That can be an JSON file, a YAML file. It doesn't have to be a single file. It can be a whole collection of files, but they should be in a single place. And you load them and apply them in your main file. My second advice is to structure your configuration settings. This is going to help you understand which settings are going to be used where. You can even add comments and things like that in YAML files to provide some extra information about what a certain parameter is supposed to do. And finally, don't reinvent the wheel and write a bunch of code to deal with configuration settings. Use a package like Hydra, because that's really going to save you a lot of time. I hope you enjoyed this video. If you did, give this video a like. Consider subscribing to my channel if you want to watch more of my content. The earlier refactoring I did of the example in this video was actually quite interesting. If you want to watch that, check out this video right here. Thanks for watching, take care, and see you soon.